Welcome to the Joseph Priestley Lecture Society at the Science History Institute. The Joseph Priestley Society, or JPS, is a volunteer-supported program that promotes a deeper understanding of science, technology, and industry, with an emphasis on innovation and entrepreneurship. Today's program is focused on the new horizons in transplantation. Before our panelists begin, I want to note that the collections and programs of the Science History Institute can help us understand the history of organ transplants, the context for this program. For example, in our oral history collection, you can trace the thinking among scientists and physicians on transplants over time. I encourage you to search our digital collections and our website, where you'll find many other stories behind the promise and complexities of transplantation. Our moderator for today's program is Dr. Maria Maccagini. Maria is the founder, president, CEO, and executive board member of Innovis Bio. She founded Innovis in May 2008 to develop better therapeutics for Alzheimer's, Parkinson's, and other neurodegenerative diseases. She is a longtime member of the Joseph Priestley Society Executive Committee. Thank you, Maria, and welcome.
Thank you so much, Grace, for the introduction. I would like to introduce today's speakers. And the first one is going to be Peter Reese. He's going to give a survey, an overview, and a historic look back at transplantation. Right now, he is a transplant nephrologist at the University of Pennsylvania and at the Veterans Affairs Medical Center, also in Philadelphia. He has 4 goals for his work. One is increase access to kidney transplantation. The second one is improving and caring for live kidney donors. I learned today that Peter and Brendan are very active in recruiting live kidney donors. I thought that was only true for the sister, mother, or daughter of somebody, but I understand there is a very active network out there because we do need kidneys. The third thing he is working on is health policies on the vulnerable. Those could be children, those could be elderly people, those could be people with certain diseases and comorbidities. And finally, he's looking at improving the health behavior of people that have had a kidney transplant, because they need to take care of their kidney so they don't lose it. The next speaker will be Brendan Parent. Brendan is our lawyer today, and he has worked extensively in the ethics of life prolongation, transplants, and how that affects human beings, be it the donor, be it the recipient, be it the family that works with these 2 patients or people, and how to improve, again, live donor selection. And finally, we have Bob Montgomery, and Bob has excellent credentials. He went to the University of Rochester for his medical degree, then to the University of Oxford in England, then to Johns Hopkins, where he started his career. And now he is at New York University. And finally, right now, he is working with pigs that have been gene modified to be more like humans, and therefore there is less rejection. So with that, I want to open it up to the speakers. They can give their 10 to 15 minutes presentation, and then we open it up for question and answers.
Great. Yep. Well, I'll get started. Well, it's really an honor to be here, to be alongside Brendan and Bob, 2 incredible thinkers in the field. And I think my job is to set the table for this talk entitled Beyond Frankenstein, Transplant Science and Life-Saving Pig Organs. I am a big fan of Mary Shelley, the novel Frankenstein, and I'm going to see the movie tonight. So I'll tell you how I feel about it at a future date. But I just wanted to start by saying that there's a really ancient history through storytelling and myth, and just human capacity for imagination about renewal through organ transplantation. Certainly, I think many people are familiar with the story of Prometheus and the idea that that in some circumstances and in some mythologies, like an organ could regenerate. But sort of following along that pathway, there have also been stories from multiple cultural traditions about the idea of transplanting organs, either from animals into humans or between humans. So you can understand how fears of death and fears of loss of function have been with us for really millennia. And just as three examples, there's a story of Saints Cosmas and Damian and the miracle of the black leg, where in this kind of Christian tradition, this idea, the story was that a dying man had a gangrenous leg, and it was replaced, it was transplanted with a leg from a different individual who had recently died. And then there's the story of Pen Chow and the heart exchange. And the way the story went is that there were two men, and the idea was that part of that the part of their personality and part of their capabilities rested in the heart. I think the story was one person had kind of a weak heart, one person had a strong heart, but the weak heart was in a strong body and vice versa. And so the hearts were exchanged. And then there is the story of Ganesha's elephant head transplant, in which a boy is decapitated accidentally, and Shiva revives him by transplanting an elephant's head onto him. So, these ideas of transplants come to us with a really long vintage. But if we shift gears and we talk about actual history, we can, I think, be easily amazed by how what seems like a recent revolutionary and incredible procedure has antecedents that are more than 100 years old. And so, often the reporting is scant and the details are less than we might want. And I have a strong suspicion that there are transplant episodes that were never reported. But in the early 1900s, there were these limited experiments with monkey and rabbit xenotransplants, people transplanting goat glands into humans, testicular tissue into humans, with promises of, revitalization or, positive health effects. And then as early as 1964, there were relatively successful transplants of animal organs into humans. I'm just going to give two examples, but one was Keith Reesma Tulane transplanting 6 kidneys from chimpanzees into humans. So these were reported. 5 patients had early poor outcomes, but one 23-year-old recipient returned to work, lived 9 months, and then died, we think, of cardiac arrest. And in this time of less scientific insight or oversight, excuse me, there also was, and these were startling accomplishments because our understanding of immunosuppression and the immunosuppression medications to sort of teach the body to accept these animal organs were so much less, so primitive. Also, there was, no modern IRBs and less demands that, scientific protocols be announced beforehand and made transparent. And also in the same decade, this giant of transplant, Dr. Thomas Starzl, he was transplanting primate kidneys and also livers into humans. In this report, he talks about 6 humans who received baboon kidneys and lived after that. They were all, uremic by report with end-stage kidney disease. They died 19 to 98 days later. He reports on, what he found when the pathologist looked at the tissue. They all had findings that we would say would be very consistent with immunological organ rejection, and also many of them had infectious complications. And after this period of these experiments, some reported, some not reported, there was kind of a moratorium that Starzl supported on clinical xenotransplant. And as the story is narrated by a friend of the three of ours, a really wonderful writer and surgeon, Josh Mesrich, in the book that I put there, which I recommend, there were hopes that deceased donor, the allocation of human deceased donor organs and chronic dialysis would kind of meet the need. So there was a move away from xenotransplant, but I think interest continued, and there were certainly some lessons that emerged even from that early period about what the potential biological challenges were. So the first one, of course, was that the human immune system would recognize these organs as foreign and attack them and reject them. And the main solution that people had in mind at the time and for decades hence was to suppress the human immune system, understand it better, suppress it, and try to do so in such a precise way that complications were limited. But there was also a lot of concern about infections, either infections from the donor organ or just because of immunosuppression, infection from the world of microbes all around us. And there was even talk about how people who got these organs might have to be under surveillance for their whole life. They talk about a Ulysses contract, so they wouldn't be free necessarily to do whatever they wanted, because if they manifested an infection, that would have to be investigated. And then, people who thought more clearly about it, of course, had worries about inflammation, disordered clotting and complement pathways, particularly for liver transplant. Concerns about, could the organs be size compatible? Would they grow to fit the body that they went into? And then, many of these organs, certainly the kidney, have metabolic and endocrine functions, either producing hormones or responding to them. And that, would all of these different, functions of the organs work, or would we have to do an organ transplant and in addition try to adapt the body to an organ that might be do too much or too little of something? And so then we had, let's say 6 decades of trying to expand human organ transplantation with human deceased donors. And what I would say about over that time, it's a period where I sort of lived through the tail end of it, where there was a lot of very innovative work to use organs that wouldn't have been used at the beginning, to basically ever expand the pool with organs from donors that would have been thought at the beginning to have contraindications. If you think about the very first living donor, that was a really healthy guy in his 20s. But over time, when we've taken organs from deceased donors, it's become acceptable to take kidneys, say, from donors in their 70s or 80s, or donors from little tiny, babies or infants or toddlers who have, had the misfortune of an early demise. Donors with diseases that could be transmitted to the recipient that, when I was in medical school, were kind of dread diseases: HIV, hepatitis C, hepatitis B, or more recently, donors who died of COVID. Donors with metabolic diseases that harm the kidney. We started taking donors with diabetes, with extreme obesity, with kidney stones, with masses in the kidney or cysts. And over time, we've certainly grown the organ pool, but depending on how you perceive it, you could think about our current situation as a wonderful success where more than 27,000 kidney transplants happened in 2024. But on the other hand, there's over 90,000 people on the waiting list, 500,000 people getting dialysis. And so another way to think about it is that it's a public health crisis that's really driven by the need for transplantable organs. And all during that 6 decades, to some degree, interest and activity and research in xenotransplant continues. At some amazing places, too numerous to name, but certainly in the Harvard system and Pittsburgh and elsewhere. And, a couple of different things happened. One was that moral sensibilities and pragmatic scientific concerns kind of shifted attention away from the idea of primates as a sustainable source of organ donors, and scientists started to focus instead on pig donors, with some of the ideas being that pigs are less sympathetic, they have bigger litters, they mature rapidly. So as an engineerable source of organs, more feasible than a chimpanzee or a baboon. And experiments continued transplanting. Now, instead of having the primates necessarily be the donor, these were experiments transplanting xeno organs, maybe, for instance, pig organs, into primates, learning about the immunosuppression, gradual incremental success. And then finally, with the development of CRISPR, big shift in focus from, during all this time, as I was, sort of mentioned at the beginning, there's a lot of focus on what can we do to the body of the recipient to make it adapt to a donor organ with, antigens or, other surface molecules that the immune system would recognize as foreign, and instead ask ourselves, how could we manipulate the organ and manipulate the recipient less. So gene editing can address cross-species incompatibilities, and this gene editing has been and can be used in two ways. One, to remove genes, but also to insert them, and then to basically grow a sustainable supply of pigs who would have genetically identical tissues. And, in the big picture, what's being done on the surface of these tissues is to engineer them to remove non-human antigens like the alpha-gal epitope that is present on the surface of many animals we think of as like cloven-hooved animals. But in addition, this engineering allows the removal of viruses that have inserted themselves into the pig genome, and also to try to address some of these physiological incompatibilities that might have to do with growth rate or blood clotting or things like that. And then with this, I think emerges even kind of another promising development, which is that what we know from clinical transplantation using deceased donor human organs is that a lot of the complications emerge because the donor organs become available at kind of unpredictable moment. So the recipient might get a call in the middle of the night and have to be rushed in for the transplant, but maybe in some cases not be as optimally ready as they could be. With this kind of bioengineered organ transplant, you sort of set the table for a different kind of a process where you know what kind of organ you want, you make preparations to kind of prepare and order the organ, and then it's ready just when people need it and put into a recipient whose health has been optimized to go through the rigors of surgery and immunosuppression. So that takes us up to some of the amazing developments of the past few years.
Peter, that was fantastic. I've never seen you give that talk, and I want to see it again several times. So I feel so fortunate to be in this room with two rock star mentors for me. Both Bob and Peter have influenced so much of my thinking on this and are also shaping the future of end-stage organ failure treatment. My job is to talk about the ethical issues, right, and questions around how we can advance xenotransplant in the safest way, in the most fair way, in the most equitable way, in a way that espouses and promotes human values and flourishing. Is my screen okay? And I'll just assume it is unless someone yells at me or throws something. Here are, a number of things that I'm doing which might influence how I talk to you about these issues. I'd be glad to talk about these at any time that any of you want to. But the most important thing is that these are my views and not necessarily anybody else's in the entire world, and especially my institution, which is one of, if not the premier organization pioneering xenotransplant. And our next speaker is at the head of that effort. So Peter already answered this question. Why even think about xenotransplant? It's because since there have been human beings with complex organ systems, those organs have failed due to entropy, and we have these enterprising physician, researcher, surgeons who have said, well, why don't we replace like with like? And we got to the point where we could do it successfully, replacing human organs inside human beings with other human organs. But we don't have nearly enough, right? The supply is inherently limited, and there are things that we've been trying to do to increase that supply which haven't made a dent to date. And we have these numbers where you read any paper on organ transplant, and it starts with over 100,000 people in the United States are waiting for an organ at any given time, and every day 17 or more people die. But really, it only scratches the surface because there are, again, as Peter mentioned, 500,000 people on dialysis and millions of people in various stages of organ failure. So it's a really unique area of medicine where the optimal treatment isn't necessarily available to the people who need it. And so how do we make decisions about who gets an organ? And this is also why we have these extraordinary minds trying to figure out new ways to provide treatment. Hence, enter xenotransplant. And Peter gave a far more comprehensive and wonderful history of xenotransplant, and it goes back much further than this. But here, are some examples of the efforts to try to heal the sick using non-human animal parts, substances, blood, and organs. And I think it's probably fair to say that there's nothing we could uniformly and resoundingly classify as a success in the xenotransplant space until very, very recently. And it has to do with the tools of genetic editing that have made it possible to reduce the immunobiological incompatibility issues, the genes that have been lost in the sort of evolutionary chain. And so now it truly is looking more and more promising in a remarkable way. And great if the science is getting there, but we still need a public that supports, right? Without people who are willing to receive xenotransplants, then the modality has no value. And we're seeing something interesting in the research we're doing about public support for xenotransplant, which is, yeah, there are a number of people who have concerns, but it seems as though those concerns are not as significant, lasting, and resistant to education, even as people were when human organ transplant became a viable treatment modality back in the 60s, right? For any of you who were there, it's a very unique thing, the idea of replacing a human organ with a deceased human organ. And that took a while for culture and values and education, sort of society, to come around to that idea. And it looks like, we already have that foundation. So xeno might experience even less sort of pushback. Okay, so the public might be on board. How do we get the science there? And as Peter mentioned, the first efforts to demonstrate proof of concept were testing one non-human species organ in a recipient that is another non-human species, so pigs, genetically edited pig organs, into non-human primates. And then eventually we exhaust the information we can get from that modality, because as we know, data in non-human primates doesn't necessarily translate to data in living humans. But maybe we're still not quite ready to start in living humans because of the extraordinary risks to inherently vulnerable patients, those who are in end-stage organ failure. Hence this idea of testing transplant research like xenotransplant in patients who are declared dead by neurologic criteria. So this is a patient pool, and I put that in quotes because do you call it a patient? Is it deceased? There's so many different names for this model, where it's a hemodynamically stable human environment with a fair bit of effort to maintain that stability, which alleviates the risks to non-human animals and living humans, where we can learn all kinds of new data. And this has produced a lot of valuable information as a translational bridge, but there are all kinds of ethical questions, including, well, if you check the box to be an organ donor, should that include having your body maintained on a ventilator after you die and having a pig kidney hooked up to it? So how do we respect the wishes and the legacy of the deceased and get adequate authorization? How do we ensure the dead are dead, right? And even though there is absolute medical consensus around death by neurologic criteria as death in fact, there remain questions and concerns from some people, and not just unreputable crazy people, about what brain death means. What are the criteria of brain death? There's iteration on how we declare death by neurologic criteria. And, promoting the rights of surviving family members. Do they get to see the deceased while the experiments are going on? How long do the experiments go on, etc.? So this model has been developed, and we've created something of an ethics framework for how to do it. And then eventually we want to go to human beings. And so one of the key questions is, how do we get informed consent from the first humans who are going to be recipients of genetically edited pig organs? Meaning, look, this is not clinical treatment yet. We do not know whether you will do any better with a pig organ than you would getting nothing, just comprehensive palliative care. So this is what we call the therapeutic misconception, which is you're not you're always a patient, but for purposes of this experiment, you are not getting standard of care treatment. So how do you go into it as a patient with the right mentality, especially a vulnerable patient who might have been told, look, we can't give you a human organ, you're not eligible, but would you try this experimental intervention? All kinds of other questions about the risks that we don't know, right? We don't know what's going to happen when we put the pig organ in. We don't know about the risks of xenozoonotic viral transmission. We can lower them by doing all kinds of screening, but we don't know what will happen until after we put the organ inside of you, etc. And then what happens if xenotransplant fails? What's the backup? Peter mentioned the Ulysses contract, the idea that if you receive a genetically edited pig organ, you're committing yourself to certain kinds of mandatory treatment and monitoring, not just for your benefit and for the benefit of that arguably precious resource, but also for public health benefit, right? To prevent that low but severe risk of some kind of viral transmission from an organ that's not native to the human body that could be susceptible to viruses. So what kind of vaccines, immunosuppression adherence, how we monitor for these potential viruses, saying, look, you're not going to be able to donate blood gametes or breast milk. And then your contacts. How many rings do we go out from the patient to say, we need to make sure your loved ones are on board, that the people who treat you are on board with this, and that they understand what you're getting into, or at least to notify them. And then how do you enforce all of these requirements? By the way, I'm not going to answer these questions. I just pose them and then other people have to answer them. Obviously, I like to help, but can't always immediately. There's a lot of work to do. I want to go back to sort of the fundamental concept of allotransplant policy, which is we're talking about how we justly distribute a scarce resource. But if we eventually get to a point where we are doing both xeno and allo, how do we integrate these? And then when we get to a point where we could potentially eliminate human organ transplant because xeno is working well, should we? Right? What does it mean? At what point do we say this is the treatment modality? We no longer need to do this arguably archaic and strange practice of transplanting deceased human organs and managing all of the sequelae and symptoms of immunosuppression. And then what happens if we get to that point? Meaning, what does it take to scale xenotransplant to effectively care for all the people in organ failure? And then do we sort of shift the goalposts and say, well, maybe we're not just treating people in end-stage organ failure. What about early-stage organ failure? Should this become standard of care in those potential arenas? And I'll quickly mention, because Bob is going to be the closer here, which is that our current federal regulatory landscape for human organ transplant only applies to human tissue. And that includes a prohibition on the buying and selling of human organs because they are a priceless, uncommodifiable resource. And so we don't want to create market incentives for human organs to then create, for example, or exacerbate this black market, which we call a red market, where people are going to other countries where they can get organs more quickly because maybe they can buy them. That doesn't apply in xeno. And so what happens if there is a market for non-human organs that industry then wants to capitalize on and corner a market and create either a monopoly or an oligopoly? And what does that do to prices and reimbursement for the primary treatment modality if xeno gets there? And then what does that do for the stratification of access to care if we have, for example, xenotransplant, which maybe becomes the ideal or standard of care, and then human transplant, which is then suboptimal, and who gets access to what kind of care based on their insurance status, their ability to pay? So we need to pay attention to this and potentially amend the federal landscape. And I'll just pose this philosophical question. Let's assume that xeno is no better or worse on balance in terms of clinical outcomes for a patient as allotransplant, human transplant. Which would you pick? All other things equal, and why? And then I ask, what would it take for you to shift in one direction or the other for the outcomes in terms of better longevity or less immunological response? And then finally, what does it mean, again, to scale? Now, look, if we scaled xenotransplant, where maybe eventually we even have a pig for everyone who might need one day, it won't look like this because these pigs have to be treated really well. They have to be clean, sterile environments. The pigs have to be cared for. Now, they won't have access to their natural ecological behaviors like rooting around in the mud and nearly as much socializing because of the risk of infection. They'll be treated better, but they're still brought into the world just for the sake of killing them to help human beings. And pigs, whether we like it or not, are morally sophisticated, cognitively complex animals, some of which are probably just as smart as my 7-year-old and experience as vast a range of emotions, right, as my 7-year-old. So if it's not about their intelligence or their emotional and cognitive capacity, what differentiates us from pigs? And you say, wait a minute, we eat billions of pigs every year. Why are we worried about the pigs for human life saving? And I'd say, well, let's flip that question and say, well, maybe we look at xenotransplant to question the meat industry. And I would argue that maybe this is a less elegant solution than bioengineered organs, where we don't need a donor pig or a donor human, and that we can grow them from the cells of the person who needs the organ in the first place. And let's also not forget increasing recovery of organs after circulatory death, more living donation, better transport of organs. Organs get lost in transit. Did you know this? And the social determinants of health that lead to organ failure in the first place. Now, this might be rearranging deck chairs on the Titanic, as my colleague here, likes to say. This might not cause a dent, but if we channeled more resources into this, how much of a dent could we make in addition to advancing xeno? And I'll stop share and hand the baton.
Thanks, Brendan. I'll pick up that baton. And what a pleasure to be here. And what great lectures have preceded mine. So there's a very high bar already established. So I'm going to talk about the past and future, but when I should probably say the current state and future, because the past is only going to go back 4 years from when we started to put gene-edited pig organs into humans. To start with, it's customary for us to list our disclosures. The ones that are emboldened here are relative to this lecture. Sorry. So, my colleagues have really addressed to a certain degree this idea of why we're doing this, and why not just use human organs. And I'll give you some other numbers perhaps that frame this. So there's a hard ceiling over the number of human organs that are available. And that's because only about 0.4% of the annual deaths in the US occur in a way in which the individual who has died could be an organ donor. So we'll never be able to necessarily increase that. The truth is that only 10% of the people who develop organ failure each year get listed for a transplant. And only a third of those individuals who get listed ever actually receive a transplant. So the bottom line really is that about 3 to 4% of Americans with organ failure receive a transplant each year, despite this being the best option for organ failure. And I think very few people fully appreciate just how much we ration human organs. Now, this has been touched upon, but the reason that we've been doing xenotransplantation research for 40 years or so of, transplanting pig organs primarily into primates is this concern about introducing new viruses into humans, something called zoonosis. And that was, I think, the main barrier to getting the FDA to permit us to begin to do gene-edited pig transplants into humans. And first, I just want to say that there's a risk, either known or unknown, of anyone who receives a transplant of getting an infection from their donor in human-to-human transplants. And in fact, I've had a heart transplant, and I purposely took an organ from someone who had hepatitis C, and I became infected with hepatitis C. Now, we have drugs now to treat hepatitis C, so I was successfully treated after the transplant. But that also, I think, puts into perspective just how desperate it is, in terms of someone waiting on the list for an organ. Now, there are various things that we've been able to engineer into the pigs to try to limit the possibility of getting the most likely types of infections from pigs. So, Brendan mentioned that we sort of found a way around this concern by performing the initial pig to human transplants in people who were already dead. So this, is a way of mitigating the risks in these high stakes type of innovative therapeutic developments. And so the initial pig to human transplants were done in people who were already dead, whose hearts were beating, and they were maintained on a ventilator while we tested these organs. And one of the most important things about these studies, which initially were only done for 3 days, but then were expanded to up to 2 months, is we were able to use very sophisticated platforms to test for infections and to determine, what the relative risk of zoonosis might be. And this is just a picture that was taken of the first gene-edited pig-to-human transplant that we did here at NYU in 2021. Now, I mentioned that we then had permission to study these organs for 2 months in a brain-dead decedent, and we transplanted this kidney into this first 2-month decedent, and it had very simple gene edits, just that a single carbohydrate that was lost during evolution, for which humans have very high levels of antibody. And we also transplanted the thymus from the pig underneath the capsule of the kidney to try to create tolerance to that pig organ. And we were able to really answer some very fundamental questions because we could take frequent blood samples and biopsies of the kidney because this person was already dead and couldn't be harmed. And we were able to really determine, Peter mentioned just how complex the kidney is, all the different things that it does. It regulates fluid and electrolytes, regulates your blood pressure, acid-base balance. It makes hormones, responds to hormones. And we just didn't know really what a pig kidney was capable of in terms of responding to human physiologic cues. The good news is the pig kidney can do almost anything that a human organ can do. And the things that it can't, it turns out that we have some redundancy in our physiology to overcome those. Now, then really it comes down to just immunology and rejection and the human immune response to these organs. And again, in this safe setting, we are able to see that these organs might experience rejection, and that rejection is something that is fairly familiar to us in terms of human-to-human transplants, but it looks a little bit different when it's 2 different species. But it does involve the same players, antibodies, and T cells. And so we were able to learn a lot about both how to diagnose this type of rejection and how to treat it. And we were able to very successfully, under these very controlled circumstances, for the first time, treat xenorejection. And that set us up then to go to the FDA and get permission to study a xenograft in a living human. And in the beginning, the first couple of these that were done in people who are in really desperate predicaments in terms of being on death's door and really not having any good options, not being candidates for human-to-human transplants. And this is just an example of one where we put a heart pump in somebody who had heart failure and kidney failure, and then used a gene-edited pig kidney. That very simple set of gene edits, just the alpha-gal knockout in the thymus. And then the second transplant that we performed in a living human, again, was somebody who was not going to receive a human organ, and we used a much more complicated set of gene edits, total of 10 gene edits. And those were either knocking out things that that humans have antibodies against that were lost during evolution, or putting human genes into the genome to make that kidney more human-like. And to date now, there's been a number of these transplants that have been done either as single patient INDs, or now we're at the point where we're actually doing clinical trials, just like you would for a new drug that you want to have available to patients. And I won't go into too much detail here, except to say that there's a very complicated gene-edited pig kidney that's made by eGenesis that's been tested at Mass General, and they, have tested it first in one of these really sick patients, and now more recently in a pilot trial in 2 other patients, one whom lived almost 9 months with the kidney. That patient is now back on dialysis. The kidney was removed. It was rejected in the end. And then the 2 patients that I mentioned. But I think what I really want to point out here is we're seeing a very nice progression in terms of the length of time that these kidneys have been functioning well. So in some of these really sick patients, in the beginning, it was a month or 2. And I think they were limited really by their other comorbid conditions. And then we performed one in a slightly healthier patient that lasted about 4.5 months, and the kidney had to be taken out. And she went back on dialysis. She's doing fine, has all the options ahead of her. And then more recently, almost 9 months. So that's a pretty rapid progression, actually much faster in terms of the length of time that the organs have survived than in the beginning of allotransplantation or human transplantation, human to human. And now we're entering into a clinical trial, which we've already started, which will involve 50 people who are more likely to die or become too ill to receive a transplant than receive a transplant, but they tend to be healthier, and we'll be enrolling about 50 patients in this trial. And this is sort of a more in-depth description of the trial. And these are all the people who are involved in this work at NYU and our colleagues and collaborators. So thank you for your time. And I think we'll go now into the Q&A.
Thank you very much, all 3 of you. This was really interesting. And yes, let's go into the Q&A and let me see who is asking. The first question is, how about religious people like the Jews or the Muslims in respect to pig implants?
Brendan, you want to take that, or Peter, because you guys have studied this kind of thing? So.
Yeah, I mean, I can start, and then I'd love to hear Peter's perspective. But we've been asking this question of various religious groups for years, and actually, most recently, I wish I could drop a chat with a link to an article that we just got published on religion and attitudes towards xenotransplantation. So I'd be happy to share that paper later. But the finding has generally been that despite religious feelings and beliefs around animals as either sacred or unclean, clove-hooved, and that saving a life always takes priority, right? And is precedent. And we ask this of religious leaders in various communities. And that's kind of the resounding answer. Now, that said, whatever the leaders and imams and priests and rabbis are saying out loud, various members of the communities could have different feelings and beliefs as well. But even this survey, and again, if I were to share it, you would see that there's significant support for the concept generally across religious groups.
Thank you, Brendan. One question is, how many organs can we transplant to date? I read somewhere that they replaced the face of somebody that had a disfigured face. I guess you can replace the leg that didn't work a 1,000 years ago. That's for Bob and Peter.
Well, Bob has done a lot of innovative work in this area. To me, the most kind of interesting, inspiring transplant case is that, there are some women who, because of the anatomy of the uterus that they're born with, they can't carry a pregnancy, but they really want to. And there now is growing expertise in having either a deceased or a living woman donate her uterus to that person. Then that woman carries a transplanted uterus, takes immunosuppression. Women like this have carried a pregnancy to term, had a healthy baby. And then what's amazing is that that uterus can then come out and the immunosuppression can be tapered off. There have been transplants of faces and limbs. And Bob has done some amazing innovations here. So I think the limit is often the availability of the organ and the costs of care.
Yeah, so there are, the solid, what we call the solid organs are kind of 5, kidney, pancreas, lung, heart, and liver. So, those are vital organs that have been transplanted for quite a long time. And then, the ones that we mentioned, but, let's not forget skin, let's not forget corneas and, the other tissues that are really important as well.
One question is that pig heart valves have been used for a very long time, and they don't seem to get rejected. Why is that?
There's really no living tissue on a pig heart valve. So they go through a process much like leather, like tanning, where, they really are, it's just the connective tissue that is left at the end of that process. So, the human immune system responds, and all animals' immune systems respond to living tissue. And so that's why, but they do, they do start to calcify and get, responses, to the fact that they're from another species.
I think that's an important point to raise, because if you think about the first question, the concerns about religious objections, that not only have valves been used, but also there are biological substances like heparin that have been derived, and valves that have been derived not just from pigs, but from cows and from sheep, that we have been giving to patients as medical treatments for many years. And so this concept of taking an organ versus taking a hormone or taking another substance out of an animal into a human as a therapeutic has been going on for a long time, but kind of in different forms, different parts of the body.
Thank you. Another question is, now you have talked mostly about pigs as for transplants and a little bit about chimpanzees, but they're too expensive. What other animals could be considered?
I mean, honestly, I think, it's for the past 40 years, we've been looking at all of this, and we've settled on the pig, for the reasons mentioned. Another worry about using primate organs is that, they're much closer to us from an evolutionary standpoint. And if there's going to be a transmission of a virus or something, it's much more likely to occur from, an animal that's much closer to us. So for all the reasons mentioned, pigs, and the ability to scale and produce large numbers are the species of greatest interest. And I think that's probably not going to change.
Okay. And then there has just been some news about a guy that was operated at Mass General and implanted with a pig kidney, and he had to have it removed 271 days after it had been implanted. Can you explain why this person opted for a pig kidney, what other option this person has or had, and how he is doing on dialysis now.
Yeah, so the two most recent patients that were transplanted, one here and one at Mass General, one at NYU and one at Mass General. As I mentioned, the NYU patient was able to keep their kidney for about 4.5 months, and the Mass General patient about 9 months. And so you see this nice progression. I think as we learn more and are also transplanting these organs into healthier people, we're seeing greater longevity. But with these trials that we're starting right now, again, the patient selection criteria is that these patients, it has to be more likely that they're going to die, and we have big databases and we have the calculators that can figure this all out. They're more likely to die or become too ill to get a transplant or to support a transplant than they are to receive one in the next 5 years. And so that's the selection criteria we're using for these big studies that are starting now. And he fell into, that category. So he really didn't have, a great option, but was much healthier than some of the early patients ever done.
Thank you. And then I think, Brendan, you said something about the FDA. How does the FDA look at research on the deceased or living deceased? And do you have to have a permit to do that, or how does that work?
Yeah, I'm going to actually pass that one back to Bob, because he's the one who's had to go through the hoops and back and forth to figure out the criteria.
So, that the FDA and the institutional review boards regulate living subjects in clinical trials. So these decedents, these brain dead individuals whose hearts are beating, they're on a ventilator, do not fall into that category. So actually, Brendan was very instrumental in some of the early ethical arguments about how these studies should be regulated, because all of this needs to be tightly regulated. And so we had to set up a separate committee for the regulation of research in the recently deceased.
But were you asking about the deceased or the diseased? The idea that these are vulnerable patients, Maria, or were you interested in the dead model?
Well, I'm not sure what to call them. They're still alive. But
okay, sorry, but I'm sorry, I just misheard.
Well, the important thing, Maria, is they're not alive, because
sorry.
I think words matter in this because these are individuals who are brain dead, and that's equivalent to being dead in our country. So it's a different situation than.
But here I want to be a little controversial. Okay,
Right.
There's this company called Bizok or something like that, and Brendan is on their advisory board, and they resuscitate brains. Okay, at least they say they do. So what is that?
So the company is called Bexorg, Bexorg, and some of you may have seen studies coming out of Yale about pig heads that were taken from a slaughterhouse and then hooked up to a blood substitute with a pharmaceutical cocktail regulated by various algorithms to re-innervate. And they demonstrated a degree of electrical activity and reversal of some of the metabolomic processes of death to a degree not previously seen. But the amount of electrical activity and the electricity in the brain was like 0.01% of what you might require for consciousness, right? According to the studies that we have seen in living human brains. But the model has been able to demonstrate proof of concept for interventions that have been dead in the water for years, like stroke, right? Stroke prevention or treatment. And so that's what they're doing. But again, this is a brain outside the human body being hooked up and showing electrical activity not coordinated. So that can cause strange feelings, and does have ethical questions around consent and authorization and how we store the brains and what we use them for. And what if you pumped more electricity into them, right? At what point would we say, yeah, we're cutting that off?
Yeah, I think, this is very relevant to resuscitating, people who've had cardiac arrest or a cessation of blood flow to their brain. And, we're currently doing the same things that we did, 70 years ago, which is CPR. And this is different, though, because once you declare a person brain dead, they don't have blood flow to their brains. That is not a brain that we could resuscitate.
Not functional.
But I am all about, because I've had a cardiac arrest and been resuscitated, and the idea that we should be doing more to trying to preserve neurologic function in the setting of, a cardiac arrest by using some of these state-of-the-art innovations. So you have to sort of think about these things, though, in different categories. That doesn't really change anything about brain death and donation after brain death or these studies. Yeah.
The time is almost up, but I wanted to ask Peter something. One of your goals is to make sure people stay on medication. And my opinion is, if I have an implant and I don't care about it and I let it go to pot and I go to pot, it's my life, right? So why is it so important that people stick to their medication?
Well, we expect that with all the transplants that we've described so far, that people will need a range of medications to stay healthy for life. And I think it is, the way I take to this question is that anyone who's going to have an organ transplant from a pig or a human needs to undergo, kind of an evaluation to make sure that they are both physically but also psychologically resilient enough to make it through and committed to a good outcome. I mean, it is a tremendous investment from society, and also actually not just from their physicians and nurses, but just from their caregivers to make it through this process that can be an ordeal. So they do maintain autonomy. They have control over their bodies, but we really wouldn't want to invite someone to go through this unless they're really committed to maintaining their health and the health of the transplant. And in the case of, I guess, any transplant that we can make right now, because we can't yet grow organs in a dish, it's a tremendous gift, usually from another human, but in the future, I guess, from a pig.
Okay, and then last, and I think we can go in the order of you talked, just in a sentence, where do you think we'll be in 10 years? So Peter, you're first.
I think in 10 years that we will have gone through a period of a lot of frustrations and setbacks, but ultimately a lot of success with transplanting organs from pigs. I think it's not going to be smooth sailing, but I think in 10 years, a lot of patients are going to be benefiting from this. And I'm really excited to play some kind of a role in that along with Bob and Brendan.
Thanks. Brendan?
Yeah, I'd second that exactly. And I would take my 30 seconds to answer Gary's question about, is there language I should put in my advance directive to give physicians the ability to receive a xeno or test a xeno or donate your organs? Tell your family. That's the most important thing you can do. Let them know your wishes, and so then they can represent those if you happen to die in a way that, could be of benefit to the future of the practice, which will help us get to the point that Peter's talking about in 10 years.
So, yeah, I mean, I agree with everything that's been said. And, I think we're seeing a very rapid evolution in just about everything in technology and science. And I am very optimistic that in 10 years, we'll have xeno organs, we'll have bioartificial organs, and we'll be creating organs from stem cells, maybe even from the patient's stem cells, where they don't need immunosuppression. All these things are really rapidly progressing. So, and not just to, replace a failing organ, but also to extend lifespan and health span. So I think we'll be replacing organs, throughout, even in, people in their 80s and 90s.
Well, thank you very much. Grace, I pass it on to you.
Thank you. And thank you all. That's been fascinating, and this will be posted online within a couple days. I'd like to just add that in addition to putting on free talks like today, the very best part about the Science History Institute is that it's free, and your gifts do power our programming. Then I'd like to remind everyone that in addition to posting these on our website, we also have some upcoming programs. We have a December 1st webinar on the history of HIV and future of therapies for HIV. There's a slide for that that is going to be displayed. And please sign up and come back for more. We have a robust series of programs, including one that will be hybrid, wine, roses, and chocolate. The others are at our usual time from 1 to 2 o'clock or 2:15, and I invite you to return. So thank you all for coming today. And Maria, thank you for your work in putting together this panel. And thanks to all of our panelists for their expert presentations and the succinct way in which they described and educated us on a very complicated series of work that they are doing. Thank you.